All right. Good morning, everybody, and welcome to this webinar. Today, we're going to talk about data platforms on Azure. I'm going to show you what your options are, and I'm going to tell you what's the best option for you. So what can you do to decide what's the best platform in Azure for you? Now, before we start the webinar, I want to tell you something about myself. So, hi, my name is Lucas. I'm a lead data architect at Prodyna. And so I'm a consultant at Prodyna. We are a consulting company. And we do a lot of stuff. We do software, we do data and AI, managed services. Go and check out our website. Now, what do I focus on? So my main focus as a lead data architect at Prodyna is helping customers make decisions regarding data platforms and advanced analytics. So yeah, this talk is exactly what I do on every day. And you know, when I deal with our customers, they always have the same questions. They ask me about, I see all of these options. We have a lot of options on Azure. Which one should we choose? I know there are a lot of services, but I'm not sure which one is the best service for me. So before I go ahead and show you all the options which you have on Azure, I would like to start and talk about data platforms in general, because sure, this talk is about data platforms, but what is a data platform? Everybody has slightly different understanding of what it is supposed to bring, what it is supposed to deliver, what kind of capabilities it is supposed to have. So I really liked one picture from Paul Andrew. He gave a talk on data platforms on Azure as well. And he had this really funny picture where on the left-hand side, he had some data sources. Then he had this magic box. And then on the other side, on the right-hand side, he had outputs. So we are just giving inputs, our data, run it through our magic box, our platform, and then we give it to somebody else. Some insights come out of it. And so we are talking about this magical box, this thing in the middle here. And, I thought before I go ahead and start to talk and make some assumptions, I would like to introduce you to what my understanding of data platform is, and what I often see, what customers actually wish a data platform to have as capabilities. So some of the capabilities of your platform might include ingestion. Of course, we have data. We may have public data, but we may also have private data. And, especially when we talk about software as a service products, it is important to know what we can actually connect to. Do we have some kind of connectors where we can easily connect to a data? We can easily pull data out of, for example, SAP systems. And can we also connect to private data sources? Because a software as a service product might not actually live inside your infrastructure, which then basically means if it doesn't live inside your infrastructure, how does it connect to data sources? So this is one capability we need to care about. And this is also what you can see in the picture. This is this connection. Now, the second thing, very important one, is storage. Sure, your data platform should probably be able to handle structured data. We know this from data warehouses, have been around forever. Now, another part might also be unstructured data. Unstructured data, well, data scientists, generative AI will most likely also work with unstructured data. And especially if you are building a data platform right now, you might deliver a platform or build a platform which has as many capabilities as you wish. So you must consider the whole scope. And when we look at storage, well, it should definitely bring capabilities of storing structured and unstructured data. Now, another topic might be big data. How much data do you have? We want to be able to grow. We want to be able to grow, and we want to be able to handle new use cases and more use cases in the future. Especially with the rise of IoT, maybe you're in manufacturing, so you're doing IoT, then with time you will get more and more data. So that's why you need some kind of a system to store this data efficiently. And maybe also streaming data, you know. When we talk about storage system, we can store historical data. We want to put it in a cheap storage, but maybe we also need something which we can update all of the time with streaming data. So this is a second capability which comes to mind. Another one might be processing. So now that we have streaming data, we also need something you see often is a speed layer. A speed layer meaning you want to be able to efficiently process your streaming data in real time, maybe. And on the other side, you have a lot, like really big data, historical data, maybe data also from which you can generate some insights based on your historical data. And historical data means basically, well, it continues to grow. It grows and grows and grows. And especially if you want to pull some insights of this historical data, you need to process a lot of data. So this is the so-called batch layer. And all of this is in the data ingestion and data processing step, which we have. Okay, next capability is probably something like enrichment. Now, nowadays, we want to not only do some basic transformation on our data, connect our data sources, we also want to apply machine learning models and connect it to AI services. You know, maybe I'm processing logs. Or I'm processing IoT data, some sensor data, and I want to be able to see if I have an outlier. Because if I have an outlier, maybe I want something to happen. So enrichment is a very important capability, especially in the future. And we want our data platform to be ready for this as well. Another capability might be serving the data. You know, it's not enough to just handle data, store data. We also want to give this data to others. We want to give this data to business people. We might want to make some reports. So visualization is actually one way to think about serving data. Maybe you also want some APIs so that people can connect via an API to your data. Or maybe SQL, you know, a lot of business analysts and also a lot of software can connect to data sources with SQL. And this might also be something that you expect from your data platform. Alerting. So I talked about generating insights. What if you generated insights based on real-time processing? You see that there is a trend of temperature in one sensor going up and up and up. And this is an anomaly. Now, if an anomaly happens, you want to trigger an action. Maybe you want to message a user. So you can already see there is a lot that our data platform has to deliver. And well, what about development? The developers might also want to do everything efficiently, and business expects everything to happen very fast. New use cases are coming and coming. And especially if the business sees that you can handle new use cases pretty fast and generate value fast, then they will be pretty happy. So you might also want your development to be AI assisted. Maybe you have pro-code users, maybe you have no-code users. What if you want all of your organization to participate in your data platform? Well, there's also the dimension of data mesh. We also have a webinar on data mesh, so you can also go to our YouTube channel and check this out. where David Wainwright is talking about data mesh. So, and this is something you might also want your data platform to have. Invitation of and participation of different users and different businesses, different domains on your data. Version control, deployment tooling. Yeah, so I just talked about the user base. Of course, data engineers will be on your data platform, data scientists, especially if you have enrichment, data analysts, and other business users. What am I not talking about? Well, a lot of things. As I told you in the beginning, there are various requirements which one can have for your data platform. So this is only a simplification. Of course, there's also auditing, there's security, there's data governance, and but we cannot talk about all of this. So in this topic, I'm assuming that we are talking about some of these base capabilities, and that's why I want to show you the services which we can actually now rely on. And this also, so you already saw we have a lot of capabilities. Now, this may not come as a surprise that because we have a lot of capabilities, we also have a lot of technologies. Now, some of the technologies on Azure are components, building parts which we can put together to build a whole data platform, while others are more complete data platforms, off-the-shelf data platforms, which we can just take and utilize. So let's look at the services quickly. We have data governance. Data governance with Microsoft Purview. You can do lineage, you can do data cataloging, basically create a different picture for your business users on your data. You can show business users, you can make your data discoverable. You can show them what kind of data products you have, which data is used for which product. Then we have real-time data. Now, we saw that maybe we might also have a speed layer, real-time processing. So that's why, even though not maybe completely a part of your data platform, but Azure Event Hub is something you will probably utilize. Why? Because it's a streaming service. It's a streaming service. You can also connect Kafka to Azure Event Hub. So if you already have existing Kafka applications, you can just switch the endpoint and just write it to Azure Event Hub. There's also stream processing. Now, let's assume we have a lot of streams, we have a lot of IoT data, we want to process it. How do we do it in real time? We have Azure Stream Analytics. It's great. Because now imagine if you have something like Spark, sure, you can also do stream processing as Spark, but it's a bit more complicated. Now, if you want an easy interface where you can just write SQL and everything else is taken care of by Microsoft, then Azure Stream Analytics is the right tool for you. Azure IoT Hub. What's all this about? Well, it's specifically tailored towards IoT use cases. So we can also do streaming with IoT, but it also brings, it brings bidirectional traffic. So you can send data, but you can also receive commands to your services, and you can build whole applications around it. Then we have raw storage, and this is super important because kind of like all or many services in Azure rely on Azure Data Lake storage. So if you want to store big data on Azure, or if you want to store data in general, you will utilize a storage account. And Azure Data Lake Storage is it's a specific option in a storage account, which is tailored towards big data scenarios. And you will also later see that, for example, if we are looking at Databricks, Microsoft Fabric, or Azure Synapse Analytics, all of them are utilizing Azure Data Lake Storage. So you should definitely know that this is an important service for you. Big data analytics. Now, there is a lot. So we have, for example, Azure Synapse Analytics. Azure Synapse Analytics is kind of like, we will also talk about it in more detail later. It's a service which came from SQL data warehouse. and it developed a bit more into a larger platform, which can handle data warehousing scenarios, but also big data analytics scenarios, where you have a Spark pool and can process like really big distributed data in an efficient manner. There is also Azure Data Explorer. And this one is really interesting because it's kind of in the middle between batch processing and real-time processing. So it's kind of in between Azure Synapse Analytics with its Spark pools and in between Azure Stream Analytics. Why would you want to utilize it? Well, it's kind of like a database also with a processing engine. So it stores streaming and time series data in a database. It indexes everything automatically. So you can efficiently do time series analysis, for example. And it's great for exactly these kind of scenarios. So it's also utilized heavily in Azure. If you see Azure Activity Log, this is exactly what it relies on, Azure Data Explorer. And so you don't write SQL, you write something called KQL. And it's kind of like a simplification, but you can also do a lot with Azure Data Explorer. Okay, there's also Azure HD Insight. It kind of fell out of favor in the last couple of years. And it's, so if you want a Hadoop cluster, if you want a Kafka cluster, if you want HBase, if you want Spark, this is what you get with Azure HD Insight. You get managed open source clusters. Either Kafka. So there are a couple of options which you have, and you can utilize it as part of your data platform if you want to be everything open source, for example. Okay, then we also have databases. Now you might ask the question, why databases? Why am I talking about databases? How is this part of a data platform? Well, it depends. It depends on the requirements, right? We talked that everybody has a different understanding about data platforms, and some people also consider databases as part of the data platform. Maybe because we might have, it must not be fully OLTP, an OLTP database, which is the backend of an application, but maybe we want to process data from logging. We want to process additional stuff, metrics, whatever, and we want to add some insights to our services. And then maybe you need a nice connection for applications, which can be then a database with which they are already familiar with. And this can also be a platform, part of your platform. So you have different SQL offerings, also from SQL Server, open source databases. And then you also have Azure Cosmos DB, which is utilized a lot in Microsoft. Okay, data modeling and visualization, super important. Now we want to be able to create reports, and especially because we are talking about Microsoft products here, we have to. Azure Analysis Services is kind of like creating a semantic model, a model of all of your tables, which are then connected together, which you can then just drag and drop into your tool, of a visualization tool of your choice. Now, if you are utilizing Power BI, you probably don't need it. But if you want to use a different tool, let's say you are utilizing Tableau or you're utilizing Qlik, whatever, then you might want to first do some data modeling with Azure Analysis Services and then give these data models to your visualization tool. And then there is Power BI. Of course, the visualization tool from Microsoft has been around forever already with data warehousing. It's a very well-known BI tool. AI and ML services, very, very important. We talked about enrichment. We have cognitive services, Azure Cognitive Services, which is a suite of services, a collection of services, which can give us translation. It can give us additional insights, entity recognition, extraction, connections to AI, generative AI, and we can connect all of this with our data platform. Azure ML Studio, well, kind of very, very similar, but it goes in a different direction of traditional machine learning services. So you can apply machine learning models and then connect it with or apply the models to your data. Data integration, we talked about connecting to your data, connecting to your private data maybe also, and also in an easy way where you don't have to write a lot of code. You can just go ahead and start. Just configure a connector and then you're good to go. This is what Azure Data Factory is actually for. App integration and utilities, well, you have a couple of them. Azure Logic Apps, Event Grid, Azure Functions, and API Management. You can combine these different services. I'm not going to talk about them right now because they're a bit outside of the scope of a data platform, but it's also very nice because you can then connect all of your data with alerting, for example, and messaging. And then we finally have our larger platforms. So we have Microsoft Fabric and we have Databricks. So these bring more capabilities, so you don't have to build individual components, but maybe you then with Microsoft Fabric, you get an end-to-end platform. And with Databricks, very similar. We will also talk about Databricks later in more detail, where you get most of the capabilities already in this product, and then you can just add some smaller components to it. Okay, so these are all of the services. What do we do now? Oh, sorry. What do we do now? What is Microsoft's opinion on that? Does Microsoft already help us with data platforms? Because obviously, yeah, they have a lot of services. What is their recommendation? How should we now continue? Now, Microsoft has something which is called Intelligent Data Platform. Intelligent Data Platform is a set of recommendations for building a data cloud solution. And you can already see some services which are very similar. So Microsoft splits this into 4 categories. It says, okay, there are databases which can also provide some powerful solutions. Now remember, this is data cloud solution, does not necessarily mean data platform only. This can also be like more modern applications which also have utilized data for OLTP storage. So we have databases. Yeah, we talked about Cosmos DB, SQL DB, Hyperscale, which is also an option of a SQL database. Okay, so what else? What else do we have? We have analytics. We already see our 2 data platforms, Microsoft Fabric and Azure Databricks. We have AI, sure. Remember, enrichment phase. We have AI Studio, machine learning, AI search, and the cognitive services. Now, earlier it was AI services. And then we have security, right? So how can we make our data platform secure? How do we do data governance? Microsoft Purview, for example. And then we have the Defender suite, Sentinel, and Microsoft Entra. Okay. So how do we actually take all of this knowledge, which I told you about, the data services, AI services, Microsoft's recommendation? What do we actually see? What do we actually see being common options? How do people choose? Okay, so I told you about Microsoft Fabric. Now, if you want an off-the-shelf platform, which is an end-to-end data analytics platform, people just go with Microsoft Fabric. Now, if you don't want to worry about building all of the integration together, if the first picture which you already saw was too complicated for you, if you don't want to really care about this, but you just want or expect these capabilities, the platform to have these capabilities, then you can just go with Microsoft Fabric. We will also talk about all of these options listed here in more detail on the next slides. Okay, what's the other option? So you can just take it, Microsoft Fabric, great. You have a platform for your whole organization, everything is fine. What if you don't want that? What if you want to have more control about certain parts, certain components? Maybe you are not utilizing Power BI. Maybe you have a different service. And maybe you also want you have a different service for real-time analytics. What else can you do? Now, a different option is to choose Databricks. And people always ask this question, okay, so I have these larger platforms, Databricks and Fabric, what's actually the difference here? Now, if you go with Databricks, Databricks is a strong base for data experts, but this is actually the point. It's for data experts. You would probably not invite your users to Databricks. You would probably not utilize a data mesh concept with it. Why? Because, well, if you are talking about data or data mesh, you also probably want to invite as many as possible, as many different personas, data personas as possible. Also, maybe some tech user, or some business users, which are familiar with some no-code, low-code tooling. They want an easy experience. They are not pro-code developers maybe, and they also want to participate. This is not something you get with Databricks. Okay, so Databricks as a strong base for data experts. You can do data science, data engineering really well. And maybe you also want more reporting capabilities, because Databricks is not coming from reporting. And you can also see the products are, you can also look at their history, and Databricks is coming from Spark. Spark is for data experts, data science, data engineers, and they are not really, they have reporting tooling, but it's not as great as the tools that have been around forever. So a common option is to just add services to Databricks. We will also see later how an architecture could look like when you actually utilize Databricks. One example would be to add Power BI or analysis services to your Databricks in order to provide some data modeling and reporting capabilities. Now, a different option might be, and especially with the rise of Microsoft Fabric, some people were asking, you know, before Microsoft Fabric, we had this product called Synapse Analytics. How do they differ? Well, nowadays, I would say if you want an off-the-shelf platform, go with Microsoft Fabric. If you want a strong base in data engineering or in data warehousing scenarios, especially because Synapse Analytics is great for data warehousing. This is where it really excels. And if you want to combine different components which you have, maybe you want to have best of breed strategy, where you take individual components or services where you say, okay, now this is really a service. It has all the capabilities that I want, and I just want to integrate it with a different service, which focuses on a different capability. Synapse Analytics focuses on data warehousing. Power BI analysis services focuses on reporting and data modeling. Data Factory focuses on data integration. Cognitive services on AI capabilities, and Machine Learning Studio with machine learning capabilities. So these are some kind of options which we have. And I would like to talk about more in detail about each one of these options. So you might be surprised, I'm not starting with Microsoft Fabric first. So this is a bit of a different order, and it will maybe become apparent why, because before Microsoft Fabric, we had something called Synapse Analytics. And if you even take a few steps back, what did we actually have? Where did we came from? We came from data warehousing. We came from data warehousing on premise, where we had business intelligence, right? We had Power BI tooling and we had data warehouses, especially in Microsoft's ecosystem, we had SQL Server. So we came from SQL Server and Power BI. And SQL Server, well, it's a database, and at some point, databases evolved into data warehousing. Oh, sorry, data warehouses, transforming from OLTP also into OLAP systems, which can then process and focus on analyzing large amounts of data. And at one point, there was a product called Azure SQL Data Warehouse. And Synapse Analytics actually evolved from this. So it evolved from Azure SQL Data Warehouse. They renamed it, but they also continued to develop it. So they added some capabilities to it. But this is also, so you can always look at the history and always then tell where do these products excel. And Synapse excels at data warehousing. It can also do big data analytics. And see my wording here. So even though it's sold as a product for data warehousing and big data analytics, most people consider it to be a gray data warehousing solution, which can also do big data analytics if you want to have everything in this platform. But if you have more specific needs, you might also want to switch or add a different product exactly for this. And that's why you might also want to combine Synapse Analytics and Databricks, which we will also see on the upcoming slides. Okay, what can we actually do with it? Well, data with Synapse, you have your data warehouse engineers. You can take them on this platform and they can now easily scale their warehousing workloads, which was not that easy before. And they can provide great integration with, or easy integration with, a lot of different services. So we have services like Machine Learning Studio. Easy. We can connect easily from Synapse to Machine Learning Studio. You don't have to worry about it as much as you did before. You can easily connect it to Power BI, easily connect it to event hubs, whatever. It has great integration. But there is a but. It's not a great place for business users or BI experts. Well, it's also a place for data experts, especially data warehouse experts. There is something there, or there is a Power BI tab into it, but it's not really like Power BI is fully integrated into it. Power BI is still a different product. They made the connection super easy. So you see Power BI kind of in it or in Synapse, but if you want to develop, you still have to go to Power BI. So it's just kind of like a link, and you see a window, which is then just showing you your Power BI reports. Okay, so one thing to say, this can only be a part of the overall solution. So Synapse, this is a platform as a service offering and has some components. So we have a workspace, we get a portal, right? So everybody can just go ahead, open the browser and can start working in the browser. You get your SQL pool. You also get something called a serverless SQL pool. They are really fast, massively parallel processing. Very easy to scale your data warehousing scenarios now. And as I told you, it can also do big data analytics. So that's why you also get a Spark pool. In addition to your SQL pool, you also get a Spark pool. And with your notebook, so you can then create Synapse notebooks. And in these Synapse notebooks, you can write some code. And then you can connect to your data sources. Okay, so it can handle structured and unstructured data, and has great interfaces. How would we actually now combine it into an overall platform? So you can see one example here. On the left-hand side, we have other data sources. Then we kind of have like streaming data. We have streaming data. So this is the speed. So we must also deal with a hot path, a speed layer. And we have structured and unstructured batch data. Maybe once a day, whatever. And in here, we might use different services. We might use Azure Data Factory, which is then either event triggered or scheduled. Maybe once a day, it will get all of the batch data and then store it in a data lake storage. Okay, so with the streaming data, we run it through Azure Event Hub, and we do two things. We can store it also in our data lake storage for the history and trend analysis. And then maybe we also require capabilities of real-time analytics. So we take our streaming data, send it to Event Hub, and we send it to Stream Analytics. So we can just process all of this data. And then we can directly make it available in real-time reports. Now, the other path looks like this. So where you might actually ask, where is Synapse Analytics? So after we loaded it into a storage account with Azure Data Factory, which is very simple, we might want to load it in our SQL data warehouse. And you can also see now, before Synapse, you don't have to actually use Synapse Analytics. You could also just take a different product, a data warehouse, but this is where it would actually excel as a data warehousing solution. And it would then integrate with Databricks, for example, for large scale analytics, big data analytics. You can do some analytics also connected to cognitive services from Azure or machine learning. You can also, if you're already happy with Databricks, you can do everything in Databricks, so you wouldn't connect to additional services. But you can now see one very important thing. We utilize components and integrate all of these components together. We take all of the easy integrations which we get because we have an easy integration from Data Factory to ADLS. We have an easy integration with Databricks and SQL, Synapse Analytics. And we use each of these products for where they actually excel. So the SQL data warehouse, the Synapse SQL data warehouse would then be taken and it would create semantic models for reports, right? So if you have more complicated reports, you might not actually want to just go from Databricks to your Power BI, but maybe you also do some additional stuff, which will make it much, much easier for your data analysts to visualize everything. Okay, so this is one example of how you could utilize Synapse Analytics as one of the components. Now, after Synapse Analytics, or Microsoft saw that many people did not utilize Synapse as they initially thought they would, because they wanted Synapse to be the overall data platform, but they saw that many people, especially people coming from Power BI, they weren't really that happy with it. So it wasn't a place for data analysts. It wasn't the best place, maybe also for data scientists. It wasn't the best place for business users. So they did a different idea and they introduced Microsoft Fabric. Microsoft Fabric now comes from Power BI. So by default, you get a much easier connection from business users and from your data analysts. And then they introduced additional data engineering capabilities to Power BI. So they kind of took like Synapse Analytics, Power BI, and they made a lot of improvements, made everything easier, better. And you could actually see Microsoft Fabric adds significant functionality to a Power BI tenant. Why? Well, because it's still Power BI. So Power BI kind of is going into the direction or has evolved into Microsoft Fabric. But now, instead of only having Power BI, you can also do everything that you have to do before you create reports in Microsoft Fabric or in this Power BI platform as well. Okay, so what do we have? Well, we have data warehousing. It's great for data warehousing. We have now great big data analytics. We have data integration capabilities. We have machine learning. we have real-time streaming, and we have more. So because we also have Power BI, and you can also see this here. So on the right-hand side in the picture, we have ingestion capabilities, we have different storage capabilities, transformation, modeling. So we don't actually, we can also do everything in here, visualizing, and then we also have governance and management. So why is this? So we get an off-the-shelf platform now, and everything runs under the same cost model. So you don't pay for these individual services, right? So if you actually remember the slide from before, we had different components, and you have to pay for and consider the cost model of each of the components. With Microsoft Fabric, you get you get your something called capacity. You get your cost model, and you can apply it to the whole platform. Okay, so how does it actually work? What is it that Microsoft actually did in here? So we have something called, as a storage layer, we have something called OneLake. Now with OneLake, you don't need to care about Azure data lake storage anymore. Why? Because Microsoft, this is a software as a service product. Microsoft takes care of that. So, but you can already see ADLS is kind of utilized everywhere in Microsoft services. So this is, so Microsoft is giving you an easier experience. You can still have data in different places if you want to have that. But they will show it to you as one layer, this OneLake layer, and everything in here. So you can put structured and unstructured data in there. But one really nice thing is that they made all of the experiences, all of the engines, the warehouse engine, lakehouse engine, the real-time analytics engine, and also Power BI, they made everything that it works with the same data format, which is great, because remember, where did we actually come from? This was one of the big problems that we had with data platforms. We had, for example, SQL Server. It had its own storage system. Then we needed to take all of this data, copy this data in a different system, and transform it into a different format. If you wanted to work, for example, with Spark, then you would have to also, you can process it. You need to take all of this and then put it in Power BI in a different format. And now you don't have that. So you don't have as many data copies anymore. Everything seamlessly works together. You can just take your data from your warehouse, transform it with, for example, T-SQL, because we have different engines now. You can store it, and then Spark can just go ahead, connect to your warehouse, and just without any copies, without any transformations, just go ahead and read this Delta Paquet format. So this is actually utilizing something called Delta Lake. So on top of your data lake, you get a Delta Lake, which brings additional asset capabilities. It's actually the same idea that Databricks has. So Databricks made everything open source, and Microsoft, Databricks, and also other people are working on improving this format. Okay, so we have all of this. We can have different engines, which is really great. So because we have these different engines and also all these different capabilities, you just get an easy experience. You get seamless collaboration, and this is one of the strong suits from Microsoft Fabric. You get seamless collaboration between data personas. You can have your data analysts working on a warehouse. You can have your data engineers working in a lake house. You can have your data scientists working with Spark on whatever data which you want. Everybody can communicate and work on the same platform seamlessly. Okay, so how does it look now? Because listen, this is a software as a service product. How can we actually connect to our data? Well, kind of like Data Factory is also part of Microsoft Fabric. It's a bit of a different data factory than the Azure Data Factory, but it still has a lot of the same functionalities. And you can make everything private if you want. So you have a private option with Microsoft Fabric, even though it's a SaaS service. You can also just deploy a private endpoint into your VNet, and have a private IP address so you can communicate via private channel with Microsoft Fabric. Now, if you don't want that, if you're fine with everything being TLS encrypted, you can also just choose the public option. Sure, on your end, on the on-prem side, you also have additional services which will then connect to your on-prem data. So you will have a component in your on-premise side which connects to your data and can send data through one of these channels which you actually set. And then you have your Microsoft Fabric, right? You can have different workspaces, which are kind of like the working areas. You can have a workspace for customers, for example. I'm assuming here you have a team which is supposed to care about customer data or do something with customer data. So they are ingesting data, transforming data, generating insights, and generating some reports. And you can also just then introduce this data mesh idea, and you can also introduce the idea of seamless collaboration between teams with no data copies, because you can just take your data from your workspace customer and make it available to other workspaces so they don't have to do the same work again. It's very easy. You can do it via shortcuts. So they have access to it with no data copy. So it's still in the workspace customer, but because they are on this one layer, this one lake, they can easily just participate and take everything and just process it however they want. And you can have, for example, a pro code team which works on your data. You can also then introduce and no-code experts, which can also work maybe on a different set of data, and everybody can easily collaborate. And this is really the idea of Microsoft Fabric: easy collaboration and off-the-shelf platform. Okay, Databricks. What's with Databricks? Because some people also might think, before Microsoft Fabric, we only had Synapse as one of the options or larger options which we had, their core components, and we had Databricks. Databricks is great. It's cloud independent. So it's a cloud independent platform coming from the creators of Apache Spark, actually. So they went ahead, they developed Apache Spark, and then they wanted to build a platform built on the concept of lakehouse architecture. So you have a data lake. You can first, in your data lake, store whatever you want, but you also introduce a structured layer in your data lake. So this is where Delta Lake, which is also utilized in Fabric, came into place. And with this Delta Lake, you then also get a compute engine, which is the Spark engine. And with time, you also got some SQL. You also got some additional capabilities. Now, how does it actually look? How is it different for Microsoft Fabric? Microsoft Fabric is a multi-tenant architecture. So it's a SaaS platform not running on your resources. Sure, there is a cost model. You can locate your cost model in Azure, but your infrastructure is running on Microsoft's side. With Databricks, it's a bit different, because with Databricks, you have two components. So first of all, you have something called a control plane. So this is shared architecture. But then you also have something then you also have your infrastructure, which is actually Databricks will go ahead, and if you want to provision storage, if you want to provision compute, it will go ahead and provision these resources in your Azure tenant. And this is actually great, and one of the big differences. Why? Because now the Databricks just goes ahead and ingests virtual machines and ingests a storage account in our tenant. We can also do a full VNet integration, which then basically means all of this infrastructure will be located in a VNet, which is controlled by us. So it means we have much more control of how our traffic is flowing, and we have much more options. We have a direct, better connection to our private data sources. Why? Because, well, this infrastructure is in our private side. So it can just take the private channel straight ahead to our data. And from our side, we can also just connect to all of the infrastructure. With Microsoft Fabric, remember, it was different. I told you about a component which has to be deployed also on premise so that you can actually connect to your private data and take the private data out of your systems and send it to your private IP address in Fabric. So it's a bit of a difference. So the integration, even though with Microsoft Fabric, you can also get a private IP address, but this is different from a full-blown VNet integration. So yeah, so what can you actually do with it? What can you actually do with it? So you can do big data analytics because you get a Spark platform, you get Delta Lake, you can do data warehousing to some extent. But if you actually look at how people are utilizing Databricks, it looks very, very similar to what we saw with Synapse Analytics. You don't see as many components as we might have because when people are utilizing Databricks as their core component of the data platform, many of them decide to take most of the Databricks capabilities, and wherever they might not be happy or need something extra, they will utilize additional components. So for example, if you don't, or if you want to utilize some of the connectors, because Data Factory is an integration service and it has really many great connectors. So if you imagine you have to pull data out of an SAP system, and if Databricks does not have a connector to this SAP system, many people will just go ahead and deploy an Azure Data Factory instead of writing all of this code themselves, because connecting to a SAP system is not always that easy. So you might deploy a data factory, so you can utilize some of the connectors. You will also have, because you saw that now, something like a data lake storage. You can also just deploy. So what many people do is deploy their own storage account, and then their own storage account, they connect it via something like a shortcut with Databricks. So they can have everything in their storage account, not in the managed storage account of Databricks. So it's an additional layer of control which you can build in here. You can also see that we are still utilizing, for the hot path, we are utilizing Event Hub, and we are sending the data now straight to Databricks because we might now utilize the streaming capabilities, streaming processing capabilities of Databricks, because Databricks takes Spark, but also adds additional features, nice features, which we can utilize to process, or to do some stream processing, for example, and also batch processing in an easier way. But it has a bit of limited capabilities when it comes to data modeling and data warehousing. So people often decide to do data warehousing. So they do big data and mostly everything in Databricks. But then if it actually comes to more complex models for the business, they integrate it with, for example, Synapse Analytics or also analysis services in order to build their data models and make them available to reports. For example, and if they are utilizing they might then utilize something like Power BI, if we are actually talking about Microsoft's products. Okay, so that's kind of it for the talk. And what do I want you to remember, actually? So in Azure, sure, we have a lot of different services. We have a lot of different data and AI services, but you have three main options here, or three options are really common. First option, Microsoft Fabric, off-the-shelf data platform, where you don't need to care about much. But of course, if you want to change things up, it will be more difficult. So if you want to easily swap components, you might be better off with a different option, maybe Databricks as your core data platform. Databricks, if you actually have a lot of data experts, mostly data experts, working on a data platform, and everybody else is kind of like a guest. So you can take the core capabilities of Databricks, and then you can kind of add additional capabilities which you require to Databricks. And then the other option would be, you know what, instead of saying one component is supposed to be one of my cores, I will just take smaller components, for example, with Synapse also, and say like, okay, everything is supposed to have, I'm going for a best of breed strategy, and I'm going to say, I'm going to do data warehousing with Synapse, I'm going to do machine learning in Azure Machine Learning, I'm going to do some data engineering and in Databricks, Power BI for reporting, and so on. So if you want the most individual platform, then you will actually then utilize more components. And one of the components will probably also be Synapse Analytics. Okay, so thank you very much for today. Yeah, if you have any questions, just go ahead, write it in the chat, and I will answer it. Okay, so I don't see any messages. So my assumption would be that nobody has any questions. Great. So thank you very much, and see you next time. Bye.